Okay, this question is about the movement of a train. The train goes from P to Q. It starts to brake at P and it stops at point Q. And we have the velocity time graph that shows that motion. So we can see that the train starts at a velocity of 45 meters per second and it stops after 39 seconds, where the velocity becomes zero. First question is asking us to find the acceleration of the train. Now, whenever we have a velocity time graph, we can find the acceleration by finding the gradient. Alright, now in questions like that, the first thing we need to say, we need first of all to identify that the acceleration will be given by the gradient. So I need to mention that. And then, how do I find the gradient? Is the change in y over the change in x, or you can have it as like rise over run, or you can find it as y2 minus y1 over x2 minus x1. There's different ways to explain the gradient. So yeah, that means we need to see the change in y. That means is the change between that point over here to that point over there. That's the change in y. And then we have the change in x over there. So let's start doing that. So what is the change in y? So it starts at 45 and then it finishes at 0. And the change in x, it starts at 0 seconds and it finishes at 39. So 45 minus 0, that's 45. 0 minus 39, that's minus 39. So if I do this calculation, I will get the answer of minus 1.2. Alright, now because it's acceleration, we know that the units are meters per second square, and we have this negative sign that is actually telling us that it's decelerating, it's slowing down though. So 1.2 meters per second is removed from its velocity in every second. That's why we have a negative sign, and we can see that the gradient, it's a kind of a downhill, which is a negative slope. So we found the acceleration of the train. Then next question is to find the distance between points P and Q. We'll write the answer here so we can see the graph. Now the same way we have defined that I get acceleration by finding the gradient, I have to define again that I'm finding the distance, by calculating the area under the graph. So I need to find the area under the line, so this area that I'm highlighting now, and that will give us the distance that it has been covered during the deceleration. So how do I find the area of a triangle? Is base times height divided by 2. So the base is that, the height is over this one. So I substitute the units, so base is 39, height is 45, same numbers I've used before, divide by 2. So if I do this on my calculator, 39 times 45 divided by 2, it will give me an area of 877.5. Yep, something that you can round up as 878. Now, what are the units? We can see that velocity is measured meters per second, so since meters is used for length, that will be meters, right? So distance, which is equal to the area, will be 878. I have attached one more graph, and I would like to practice this again. Find the acceleration of the first part of this part over there. So remember, again, we always start by saying acceleration equals the gradient. And this is only applies for velocity time graphs or speed time graphs. Then I need to find the change between the starting point and the final point. So this one has started at 15 and it has finished at 30. So my gradient will be again y2 minus y1, change in y, x2 minus x1, change in x. So we started at 15, we finish at 30, and in terms of time we started at 0, we finished at 10 seconds. So therefore it will be 15 minus 30, that's minus 15, 0 minus 10, that's minus 10. The negative signs, when I divide negative divided by negative, becomes positive. So 15 over 10, that will give me 1.5. So once again, because we're looking at for acceleration, we can see that it's meters and seconds. Then the units for acceleration will be meters per second squared. And if I want to find the distance covered during that part, once again, distance can be calculated using the area. And in this case, I need to find the area under that line. I need to find this area over here. So what I can do, I can split these into two shapes. Oops. So I can say that I have area 1, which is a triangle, and area 2, which is the rectangle. So what is area 1? Because it's a triangle, again, base times height divided by 2. So base is 10, height, I'm looking at the height between here and there. This is the height over here. So we 15 until to reach 30, that's 15. Divided by 2. So that will be 150 divided by 2. Therefore 75 meters have been covered in the first part. And then to find the second part, area 2 is a rectangle that will be width times length. So therefore we're looking at 0 to 10 and then 0 to 15. 10 times 15, that's 150 meters. And this is the area of the second part. So the total area will be just by adding these two. So total area, it will be 75 plus 150, 225.